Now, after this presentation, what all we are going to understand is the history of development of microprocessors and microcontrollers. We are going to have a glimpse of the Moore's law, evolution of the IC technology, that is very important in understanding because that is the basic of a microcontroller or a microprocessor in that case. What are the basic differences between a microprocessor and a microcontroller? You'll get to know of that. The application part of microprocessors and controllers, how to choose a particular microcontroller, what should be the criteria, and finally, inside a 8051 microcontroller. Now, before we study what a microprocessor is, I would like to know from you, how do you understand what a CPU is? What is your understanding of a CPU? All of you work on computers, right? Everybody works on a computer, and you know what a CPU is, central processing unit. So what is your understanding of that? What do you think?
Madam, our mind also work as CPU.
Mm-hmm.
बेसिकली अगर हम कुछ देखते हैं फिर जो हमारे दिमाग में वर्क होता है उसी हिसाब से हमारी बॉडी ट्रैकिंग करती है.
हाँ, तो सीपीयू करता क्या है? That is what I want to know from.
Arithmetical and logical functions is done by CPU.
Arithmetic and logical functions is done by CPU. Very right. What else?
Control.
The control part. Okay. And
input लेता है और उसको output.
very right. Very right. So what you are trying to tell me is that a CPU basically takes the input, it processes that according, as you said, arithmetic and logical operations and everything, and then it gives an output, right? So that is like you gave an analogy of your brain as well. So basically, if you put all the CPU on a single chip itself, जो हमारा ये कंप्यूटर का CPU है, अगर हम इसको एक सिंगल चिप में दे दें, so that is nothing but a microprocessor. So a microprocessor, if I define it, it is a programmable logic device which accepts the digital data as input. Okay? It processes that input or data according to the instructions which are stored in its memory, and then it gives the result as an output. So in a layman language, I can say that a microprocessor is nothing but a CPU on a chip. Okay? So in the graphical form, if I say this is a microprocessor, but do you think a microprocessor or the CPU alone can it work? No. In order to make it a complete unit, complete functional unit, we need to externally add some components to it. For example, memory, ROM, RAM for the data storage, for the program storage, we need to add certain more like timers, counters, input output ports, etc. in order to make it a complete functional unit. Another thing is that when you interface the microprocessor with the real world, अगर आपने इसको एक real world के साथ, because mainly तो आपने क्या करना है, आपको इसको करना पड़ेगा ना real world के साथ interface, then you also need to add to it certain ports. Always remember, a microprocessor does not have any input output ports of its own. So in order to interface it to the real world, we need to add one chip to it. Does anyone remember what is the name of that chip? You must have studied it in your BTech also. Yes? 8255, right. So 8255, that is programmable peripheral interface. So all these things, they make a complete microprocessor based system. So a microprocessor alone is not able to do anything unless and until you add all these features externally to the microprocessor. But our main aim was, like what I said was that you are putting a CPU on a chip. So हमारा मेन एम क्या था, हमने मिनिचराइजेशन कर दी थी चीजों की. बट जब आप ये सब चीजें ऐड करते तो वो होल सिस्टम बिकम्स वेरी बल्की इन नेचर, बल्की हो जाता है. और आप सोच सकते हैं क्या इसमें ऐड हो जाता होगा? what else can you think? मेमोरी तो आप उसमें ऐड कर रहे हैं ना, लेकिन उसकी वजह से एक तो सिस्टम जो है वो इट हैज बिकम वेरी बल्की. What else can you think? What additional liability it is going to make on the whole system? It is the system becomes costly also, because आप ये सब चीजें जब आप इसमें एक्स्ट्रा ऐड करते हैं तब आपका होल सिस्टम कॉस्टली भी हो जाता है. एक या दो यूनिट में डजंट मेक एनी मच डिफरेंस, but when you have to make an application wherein you have to make lots of products for let's say hundreds, thousands, lakhs of units, वहाँ पे cost जो है वो बहुत important major role play करता है. So that is where the concept of microcontroller comes into picture. We have seen that in order to make the microprocessor a complete functional unit, you need to add what all? Memory, timers, counters, RAM, ROM हो गया already, and then for serial data interfacing, you need to add ports, serial data ports, ये सब आप इसको ऐड कर रहे हो, and then of course input outputs also. But if I make all these things also on a single chip itself, that is nothing but a microcontroller. So you can say that a microcontroller is an integrated chip that performs a specified task according to instructions stored in its memory. I will discuss all these terms, both microprocessor and microcontroller, in more detailed way after some time. But before that, always understand that microcontrollers are nothing but a computer on a chip. अगर हम एक लेमैन के लैंग्वेज में बात करें, तो वेयर एज माइक्रोप्रोसेसर को अगर हम लैंग्वेज में बोलते हैं तो हम क्या कहते हैं? दैट इज अ सीपीयू ऑन अ चिप. But a microcontroller is a computer on a chip. So in the pictorial form, we can say that if you are putting all these things, RAM, ROM, serial data, and then your timers, counters, input output ports, you need not externally add any input output chip. जैसे उसमें हमें 8255 add करना पड़ रहा था, microcontroller has got its own ports for real world interfaces. So all these things on a single chip itself, that is nothing but a microcontroller. Okay. Got the point? So अगर इसी चीज को हम पिक्टोरियल फॉर्म में अगर बात करें, so this diagram is giving a very beautiful way of depicting the difference between microprocessor and microcontroller. Here you can see that in a microprocessor system you have a CPU, that is nothing but your microprocessor, and then your RAM, ROM, the memory, then your input output ports, 8255 PPI chip, then your timers, counters for timing operation, for counting operations, and serial COM port for the serial data interfacing. All these things are externally added to the CPU. Whereas in case of a microcontroller, all these components are on a single chip itself. So this is a very important diagram wherein in the pictorial form only you get the whole idea. Before I more discuss about microcontrollers, let me have an understanding from you, like what all differences can you think from this? One thing is that, as I told you, in the microcontroller all these things are on a single chip itself, but what else will these features make the microcontroller different from a microprocessor? Can you think of? Size, of course, because in case of a microcontroller all these things are on a single chip itself, so it is very compact in size. What else? Yes? Cheap. This is a very important factor, because as I told you some few times before, that because in case of real world applications wherein you have to make products in lakhs of units, there the cost plays a very important role. And because it comes in a single chip itself, microcontroller is very cheap as compared to a microprocessor. In the market, you get a microcontroller for as low as 50 rupees also for your application, depending upon your applications. Okay. Okay, what else can we think? One is bulkiness, one is cost, then processing time. Okay, yes. About the processing time, I would like to deliberate one thing. There is debate going about the processing time, but before that, I'd like to tell you about this term general purpose. As you can see from this diagram also, it is written general purpose microprocessor. This is a very important difference between a microprocessor and a microcontroller. In case of a microprocessor, when we say it is a general purpose, that means it can perform a lot number of functions. For example, your PC, your laptops. Okay, so in all of them are them contain the CPU or your microprocessor. So in your PC or your laptops, what all you can do? You can write your Word program, you can run your PPTs, you can see a video, you can email the things, and lots many things you can do on a PC. So there are a lot of things. So that is why we say that a microprocessor is a general purpose. It is not specific to one task. Whereas a microcontroller is a dedicated one. It is used in dedicated applications. That's why we say embedded system. Embedded system जब आप बात करते हैं तो वहाँ पे microcontroller आता है, because microcontroller does only one thing. It's only for a specified task. That is one of the main another difference between a microprocessor and a microcontroller. Now coming to the speed part. Speed in case of microprocessors, because we are saying that it has to be general purpose, they have to be very fast. For example, your PCs, अगर आप अपनी PC की बात करते हो तो you say gigahertz, the range of gigahertz. Whereas because microcontroller has to do only a specified task, it need not have the speed in terms of gigahertz. It can do the things well in a few megahertz. Now, another very important thing is that In case of a microcontroller, you don't have very much control or the versatility because all of the things are embedded in a single chip itself. Whereas a microprocessor, because you are adding all these things, RAM, memory, timers, counters, input, output ports externally to the microprocessor. So you have got, being an engineer, you have got more versatility in terms of what all things you want to add to it. For example, in case of a microcontroller, 8051, you have a limited on-chip memory because that has been provided on chip itself. Of course, there are ways of externally interfacing to that also, but in that case, you will have to sacrifice your ports for that. But whereas in case of a microprocessor, because you are externally adding all these things, so you have more versatility. That is another very important difference in between a microprocessor and a microcontroller. Now coming to microcontroller, what are the various applications? In daily life, we see a refrigerator, music systems, televisions, microwave, then your cameras, printers, washing machines. So all, yes,
just reconnect with one.
हाँ जी,
Reconnect to it.
तो क्या कह रहे हैं?
Just reconnect with the microphone.
अच्छा अच्छा, okay. So in daily life, where do you find microcontroller? Almost in everywhere. Even you may not be aware of that you have been using microcontrollers, though many of you are studying it for the first time. Where in every application wherein there's a specified dedicated task, you have a microcontroller in it. So they're present in everyday life applications. Now coming to the history of development of microcontrollers or a microprocessor in that case. Now we know that in 1939 we had the concept of vacuum tubes. वहाँ उस टाइम पे vacuum tubes हुआ करती थी. But vacuum tubes के कुछ disadvantages थे. Does anyone of you know about the disadvantages? They used to generate a lot of heat, a noise. They were very huge in size. Power बहुत consume करते थे. ठीक है? So with time, in 1947 came the concept of transistor. Now this transistor revolutionized the whole industry. That is when the concept of solid state came into picture. Transistor. Okay? It had all the advantages which the vacuum tube had. All the disadvantages of vacuum tube were overcome by the advantages of transistor. It was smaller in size, consumed less power, generated less heat. Okay. And then in 1965 came Moore's law. I'll discuss more about this Moore's law. Now, what was this Moore's law? Basically, Moore's law is not any established law as such. It was just an observation. In that time, there was one scientist called Gordon E. Moore, and he was at that time the R&D head of Fairchild Semiconductors. So what he was asked for, because as I told you, transistors had already come into market by that time. So he was asked to that what is in his opinion, that in a gap of 10 years, what will be the transistors market. So what he observed was that in 10 years time, because at that time it was 1965, that in 1975 there will be around 65,000 transistors in a single chip, because by that time the concept of ICs had already come into picture, integrated chip. So he said that by in the next 10 years of time there will be around 65,000 transistors which will be embedded or which will be integrated in a single chip itself. So when in and this statement he gave was in the 35th anniversary issue of a magazine called Electronics. He had written one article on cramming more components into ICs. उसने एक ये बहुत important article लिखा था. This is for your general knowledge I'm telling you about that how the development of microprocessors took place. Because this later on in 1975 when actual meeting took place, one IEEE meeting took place, and one of his colleague, he gave it the term Moore's law, because in that meeting what Moore had said that the number of transistors in dense ICs will double after every 2 years. This is the statement he gave over his observation. What he did was he observed that in the last 10 years how the transistors, they are getting integrated, more and more transistors, they are getting integrated into the IC, integrated chip. So he said that in coming times, after every 2 years, the number of transistors per dense ICs will get doubled. Now, there is one misconception. What most of the people say is that Moore had said that the number of transistors will double in every 18 months. This is what you will read also in most of the things, but that is not actually true. That statement was actually given by one of his colleagues whose name was David House. Moore has always denied that I never said it was 18 months. He has always said that the number of transistors in IC will double in every 2 years. So at that time, this statement came to be known as Moore's law. And this was a very remarkable thing in the development of the ICs. So as we've already seen, vacuum tubes, transistors, then ICs, they came in 1960. And in 1971 came microprocessor. Microprocessor was firstly manufactured by a company called Intel, which all of you are aware of. It's a household name now. And the first microprocessor which was manufactured was 4004. It was a 4-bit microprocessor basically. And after that, of course, more and more developments took place in the field of microprocessors. Now, one more interesting fact I would like to tell you about microcontroller is that most of the people say that the first microcontroller was also manufactured by Intel, but it is not so. The first microcontroller was manufactured by around the same time in early 1970s only by Texas Instrument engineers. They manufactured the first microcontroller because most of the places you will study that the first microcontroller was developed by Intel and that was 8048. No, the first was by Texas Instrument and it was TMS 1000. TMS 1000 was the first microcontroller manufactured by Texas Instrument, and then Intel followed it, and they launched the first controller in 1976. That was 8048. Of course, after that, more and more controllers came into picture. Now, coming to the microprocessor, when I'm saying that the first was 4-bit microcontroller, that is 4004, it was basically manufactured for a commercial this thing, your calculator. एक कैलकुलेटर के लिए सबसे पहला आपका माइक्रोप्रोसेसर बना था एंड देन दे थॉट दैट व्हाई नॉट यूज इट फॉर स्पेसिफिक more number of applications. And then your 8-bit microprocessors came into picture, your 8085, which mostly the students study in their curriculum. And then 16-bit microprocessors, 8086, 80186, 286, then 32-bit, 80286, and 386, 486, Pentium Pro, and so on. So this is how the microprocessors, they came into, more and more development took place in the case of microprocessors. So this is the evolution of the IC technology. If we see in terms of technology and number of transistors and their typical products. In 1947, only technology available was transistor. Of course, only one transistor. There was no concept of IC, integrated circuit, at that time. And then in 1950 to 1960 came discrete components. Again, they were junction diodes, transistors. These were the products. And then in 1960s, the concept of small scale integration, as I told you, ICs, integrated circuit, wherein you could cram more and more transistors in a single chip itself. And at that time, these terms called logic gates, flip-flops, they were invented. And then in 1966 to 1970, medium scale integration. At that time, around 100 to 1000 transistors were embedded in a single IC. And the typical products were counters, decoders, adders, etc. And then in 1970s, large-scale integration. So all these microprocessors and microcontrollers, they were invented when the concept of large-scale integration means you could cram more transistors as 1,000 to 20,000 transistors in a single IC, 8-bit microprocessor, microcontrollers. And then in 1980s, the concept of VLSI came into picture, that is very large-scale integration. At that time, around 20,000 to 50,000 transistors in a single IC itself. And therein you had your 16-bit, 32-bit microprocessors, DSP chips. So आपके DSP processors हैं, all of them are very large-scale integration, wherein you have a large number of transistors in a single chip itself. And then after 1985, the concept of ultra-large-scale integration, wherein you had more than 50,000 ICs, transistors in a single chip. Therein you had this 64-bit microprocessor. More and more, why am I telling you all these things? That the number of transistors in a single IC, how is it going to make any difference? Can you tell me? And today, in 2012, Intel launched a 62-core Xeon PHI, in which it had, 5 into 10 raised to power, how many? 10 raised to 10 transistors in a single chip itself. So can you imagine the density? As the density is decreasing fast, it is becoming more fast, things are becoming more accurate. And what else? 8 bit, 16 bit, 32 bit, 64 bit. How is it? What does it mean? As I said, the first microprocessor was 4 bit, 4004, then 8 bit, then 16 bit, 32 bit, now it is 64 bit. How is it making a difference? What does it mean? Yes, from the centers also. The centers, nodal centers who are connected to us. I want an answer from you also. What do you mean by this term when we say 16 bit, 32 bit, 8 bit? Can anyone answer? Yes, our students.
Number of tasks can be performed at the same time.
Number of tasks,
So,
then
so
we.
many number of tasks can be
No, no. It is the size of the data bus basically. See, we have two things because in this lecture I'm going to cover very basic things. Huh? There are two things. One is the data bus and the other is the address bus. So when we say 8 bit, 16 bit, 4 bit, 32 bit, 64 bit, that means the size of its data bus. How many bits of data can it process in a single time? That is your data. For example, if you go from Chandigarh to Delhi, earlier it was a single laning. It used to be, I mean, when you have a single lane, what the total time you take from reaching from Chandigarh to Delhi, it is very large. Then it became 4 laning, and if it sometimes becomes 8 laning. So at a single time, how many cars can pass? 8 cars can pass. So what difference will it make? You will be able to reach Delhi from Chandigarh in a more fast time. That is why you become very happy ना. जब भी 4 लेनिंग हो रही होती है तो आप बहुत खुश हो जाते हो. क्यों खुश हो जाते हो? Because अभी हमारा ट्रैफिक जैम्स रिड्यूस हो जाएंगे, आपका टाइम बच जाएगा. Similarly, in case of the concept of microprocessors and microcontrollers, as the number of bits, as the number of data size, data bus increases, the total processing time it also reduces. पहले के जो microprocessors होते थे वो बहुत slow थे. Now you have so fast microprocessors. 64 core हम बात कर रहे हैं. They are very fast. It is because of the size of your data. So in 2012, that Intel launched a 62 core Xeon PHI microprocessor. It's very fast. Now coming to the applications part, as I told you that a microprocessor, because it's a general purpose microprocessor. General purpose hai, so you can find it in your desktops, PCs, laptops, servers, then workstations, supercomputers, depending upon 32 bit है कि 64 bit है, आपके microprocessors वहाँ पे use होते हैं. And microcontrollers we've already seen. Some examples are your consumer electronics. Consumer electronics में क्या आता है आपके? Toys, cameras, camcorders, robots, toys, robot toys. Then consumer products, washing machine, microwave, then your TV, music system, etc. Then smart instrumentation. Nowadays, a term called intelligent instrumentation is it's called the buzzword, I can say that. So therein, the instrumentation, in the smart or intelligent instrument, you have a microcontroller embedded into it. So it can take decisions of the control on its own. Whatever input it is getting, so it can take decision on its own and accordingly give the output. So that is where the concept of intelligent instrumentation comes into picture. Then in the process control, automation in industries. We have one session, I guess today itself in the afternoon, industrial applications of microcontrollers. There you will see that how microcontrollers are being used in the industry for developing for the automation part. So this thing you are going to see. Then in the communication part, we have handsets, answering machines, cordless phones. There you have microcontrollers, offices, your printers, fax machines, multimedia, your mobile phones, PDAs, etc. So this picture, as you can see, this is basically the controller board of a washing machine, because I'm talking about application part. So this we all operate a washing machine, okay? So there is a microcontroller inside it, और उसका जो ये this, as you can see here, this is a controller board, और ये जो circle किया हुआ, this is nothing but a microcontroller. So this knows that these are all the switches, okay? So it knows that whichever switch is pressed, so the microcontroller will decide which action it has to take. It has to take. For example, if a switch on is pushed, so it knows that I have to start a relay for starting on the washing machine. Similarly, there are other control processes also. So this is one typical application of the microcontroller. Now coming to the practical aspect of a microcontroller, what all you need to know about to work on a microcontroller, हमें क्या क्या पता होना चाहिए एक माइक्रोकंट्रोलर पे काम करने के लिए. One thing is the hardware design. Today in the morning session, director sir was talking about hard skills and soft skills. So if we talk of the microcontroller also, there are two things: hardware and software. So hardware part you need to know because that is what you're going to design. So for that you need to understand the what is the microcontroller pin diagram. So all these things I'm going to cover tomorrow. And today I'm just going to give you a glimpse because we have very much less time left. So I'm just going to give you a glimpse on this. That for the hardware design, you need to know the microcontroller pin diagram. Also, how to interface it with the real world. Then coming to the software program, you need to understand how to develop the code. So the code development is basically the software part. So wherein you will understand that what are the machine language, what is assembly language, what is high level language, C level language. So once you understand the hardware design, once you understand the software design, then you will have to know that how to make a low cost embedded system using a microcontroller. So when you see this term making a low cost again, we have seen the microcontroller's advantage over a processor is that it is low cost. And embedded system. Why I'm saying embedded system? Because we are going to design a product which performs a specified task. Only a defined task. उसने एक काम करना. The work of washing machine is to wash the clothes. You're not going to warm your food inside a washing machine. Or do you do that? No. Washing machine का काम है to wash the clothes. Similarly, a microwave has to warm the food. ठीक है ना? तो आपके dedicated applications है जहाँ पे microcontroller हमने यूज करना है. So for that, I'm going to tell you that once you write your program, how to make hex file out of it using Keel compiler and what are the programming tools. Once you make a hex file out of it, how to burn it into the controller. So the last part, the first two parts, hardware design and software code development, I'm going to discuss in tomorrow's morning lecture, which is going to take place from 10 to 1. Yes, is there any query?
No, they just
okay. So and about this last part, that how to actually implement the things, that we are going to discuss on Wednesday, the Keel compiler and the universal programmer. So this part I'm going to cover in that. Apart from that, the practical applications and other practical design aspects and working on the kits and all, you're going to see in the various expert lectures. So details I'll cover in tomorrow's lecture, but just to give you a glimpse about programming the microcontroller. See, basically, once we learn the hardware, when we program the controller, we need to understand that what are the programming languages. All of you are here, but you may all not be speaking the same language. Somebody may be from Himachal, somebody may be from Punjab, someone may be from Haryana. You all have your own languages, right? But ultimately, in order to understand each other's language, we are speaking a single language, so that you understand my language and I understand your language. Similarly, microcontroller has also got different languages, but they are for our own understanding. It understands only a single language, and that is the machine language. Microcontroller सिर्फ एक language को understand करता है, and that is machine language in the terms of zeros and ones. That's it. But and this was the machine language was in fact the language which was initially developed by the programmers, and they used to write their code in this language only. But with time it was very cumbersome to write your program in the machine language. हर बार आप zeros ones के code अगर आप लिखते हो तो आपके लिए easy नहीं है program को लिखना भी और उसको decode करना भी. It is not easy for you. ठीक है? And then the programmers, they came up with the idea that let us make one language, one programming language, which is easier for us to write, which is easier for us to decode. And that is how the concept of assembly language took place. So assembly language basically consists of English-like words which are known as mnemonics. Mnemonics, for example, move, add, jump, etc. So these are English-like words, more easy for us to write a program into. ये हमने लिख लिया, but controller again will not understand this language. So you need to convert this assembly language into machine language with the help of compilers. For example, a Keel compiler. ठीक है? अगर आपको याद होगा जब आप microprocessor पे काम करते थे in your BTech, या those who are teaching microprocessors in your curriculum. So what you do in your hardware, in your lab process is that you write your program in the assembly language and then you have a lookup table. Remember, आपके पास एक लुकअप टेबल है, मूव का आप देखते हो, अच्छा मूव ए बी, उसका लुकअप टेबल में से देखिए हेक्स कोड क्या है, एंड दैट यू टाइप into your microprocessor board. So we are fortunate now that we don't have to do that practice anymore. There are, what is a compiler basically? It is nothing but a program only. So you write your program in assembly language, you write it in the compiler, it will automatically convert it into the hex file. Hex file is nothing but your machine language. But again, assembly language का भी एक disadvantage था, that it is very machine specific, that a program which is written for a particular controller or processor will not work on the other processors. ठीक है, अगर एक लैंग्वेज आलोकदीप को समझ में आता है तो वो प्रशांत को समझ में नहीं आएगा, ये एक डिसएडवांटेज हो गया. So then the programmers they came with an idea that let us make one language which can work on all the controllers. हम एक ही प्रोग्राम बनाएंगे and that we can burn on all the controllers. So that is where the concept of high level language came into picture. So high level language programs, languages के example बता सकते हैं? C, C++, Java, yes, Fortran, Basic, COBOL. But for microcontroller, the high level languages is most popular is C. And that is what I'm going to tell you also in your curriculum later on. But again, high level language आपने लिख लिया, controller does not understand it. You need to convert it into the machine language, and that is where the concept of compiler takes place. In case of assembly language, you need an assembler, whereas in case of a high level language, you require a compiler. Always remember this. Now machine language, your C language has got a lot of advantages over your assembly language. One is, as I told you, it is portable. The program which you write for a one particular machine can work on every other also. It's easier to write your program in the C language as compared to your your assembly language. Why? Because जहां आपको assembly language के 3-4 codes लिखने पड़ते हैं, वहां पे आपका C language में एक single instruction से काम चल जाता है. So the overall program size is also very small as compared to your assembly language. आपका program comparatively is less lengthy in case of C language. And then you have some ready-made codes. They are available in the library and you can use them as such. आपकी लाइब्रेरी में, कोड लाइब्रेरी में अवेलेबल प्रोग्राम्स ऑलरेडी हैं और आप उनको एज सच यूज कर सकते हैं. So these are the various advantages of the C language over the assembly language. But there is one disadvantage of the high level language over assembly. Does anyone know that? If you are aware of assembly language, C language, high level language, yes, centers. Does anyone know any disadvantage of high level language over assembly language? No answer? So I'll tell you one disadvantage of C language over assembly language, and that is, see, when we are working on a microcontroller, then one thing is very important, and that is the on-chip memory. As I told you when we were discussing the differences between a microprocessor and a microcontroller, that a microcontroller has got limited on-chip memory. आपके पास इतनी 4K की memory है, इसी से आपको काम चलाना है. So being a programmer, you have to be very careful in writing your program. हमारी मर्जी नहीं, हम जितना मर्जी बड़ा program. So being an intelligent programmer, you have to write your program as small as possible. Program in the sense hex code. No doubt, आप you will tell me, मैम आप ही तो अभी बोल रहे थे कि C language तो comparatively small होती है, smaller program होता है as compared to assembly. But always remember that the hex file which is created in case of C language is larger as compared to assembly language. Always remember this point. And that is a disadvantage. Why? Because ultimately आपने microcontroller में what are you going to burn? That is your hex file or your machine language. और उसका size is very critical. That size is very critical. So that is one disadvantage of the high level language over the assembly language. So what all, as I told you, that firstly, in the case of microcontroller programming, a code is written for the microcontroller in an integrated development environment. हम उसको बोलते हैं IDE. You write a program code. It may be in your C language or it may be in your assembly language. Keel compiler का एक IDE होता है, and then that IDE debugs the code for errors. If there are no errors, then it will compile it into the binary code or your hex code, which is then microcontroller executes, which is burnt into the hex microcontroller. And how is it burned? A programmer. So a programmer is used to transfer this code from the PC, because this code in the IDE you will write in your PC, and then it will be transferred from your PC into the microcontroller, either by using a universal programmer or you will use an in system programming. So all these things I'll cover on the Wednesday lecture, that how practically actually it is done in the pictorial form. So this is the IDE I was telling. This is now this IDE, you write a program, the compiler will convert it into the hex file, and through this programmer, this is the programmer, it will be burnt into the microcontroller board. So this is your board which contains the microcontroller. This is how practically it goes. Actually, we don't have much time left. Otherwise, I wanted to show you one video on applications of microcontroller that I'll do tomorrow. In our tomorrow's lecture, I'll show you the video. So, any doubts? Any doubts till now? And from you also? कौन-कौन से centers हैं अभी?